Another product that we can make from our amine nucleophiles is enamines. So enamines, they have a double bond next to the nitrogen, so a carbon-carbon double bond next to the nitrogen, and that's where the enamine comes from. So the amine part comes from the nitrogen, and the ene part comes from the carbon-carbon double bond that's right beside it. So that's a type of functional group, the enamine. And we are going to have the first 5 steps be exactly the same to get to that key intermediate as we saw with the other derivatives, this time with a secondary amine as a nucleophile. So the nitrogen is attached to 2 carbons. We're going to end up with doing another proton transfer, but instead of taking the proton from the nitrogen, because we don't actually have a proton on the nitrogen anymore, we just have alkyl groups. And so instead of taking that proton from the nitrogen, and also instead of doing a nucleophilic attack like we saw with oxygen and sulfur, that nucleophilic attack is pretty hindered with something like a secondary amine. So what's going to happen instead is they're going to take the H from the carbon that's beside the carbon that's doubly bound to the nitrogen. So that's where we're taking the H from. We're going to put the electrons down to make that double bond, and then we're going to break this bond onto the nitrogen itself to give lone pairs and make that nice and neutral. So we're still alleviating that charge, but instead of doing it from taking an H from the atom or attacking the carbon that's doubly bound to the atom, we're actually going one step further away and taking the H from the carbon beside the one that is doubly bound to the nitrogen, so we can push the electrons nicely in to make this neutral enamine. So let's see an example of how we're going to do this in this reaction. We have our carbonyl, we have our acid, and we have our amine. In this case, it's just an NH with 2 alkyl groups. So it's secondary. That means we're going to be making an enamine. We're going to do our protonation step first. That's going to look exactly the same as it has in our previous reactions. We're going to have that delta plus at the carbon. Now it's activated. We're going to then do a nucleophilic attack with our CH3NH. So we can just draw those CH3 groups out as the little lines. You can also put CH3 at the end if you want. This is going to be our nucleophilic attack step. And then we're going to get our tetrahedral intermediate. We'll put the OH on the left-hand side as well, just to be consistent. And then because our nucleophile comes in with its H, we do have it positively charged originally. We're going to have to alleviate that charge. We can use water, or we could use another molecule of the amine to help do this proton transfer here. So this was our proton transfer off step. That's going to give us this tetrahedral intermediate that's nice and neutral. Can be difficult to figure out what to do with the tetrahedral intermediate that looks like that, but because we still have acid present and we still have some nucleophile left that can also act as a base, we are going to end up transferring the charge to this OH group and making it leave the molecule. So this one would be the proton transfer to the leaving group, which is the OH in this case. The OH is going to go grab that H, just like we've seen. This part of the mechanism is exactly the same so far. We're almost at our key intermediate. Now we have water ready to leave. We're going to collapse that tetrahedral intermediate using the lone pairs on the atom that used to be in the nucleophile. And then we're going to get to our key intermediate. This time, that nitrogen has both alkyl groups attached, so there's CH3, so we can't just take an H off here because these are CH3s. And so we also, because of how hindered it is, we don't want to tack directly there, so we're going to take an H from the carbon beside. So we can just draw out that H. So now we're going to take the proton off of that carbon. To do that, we can use another molecule of our nucleophile that can grab that H. The electrons can go down into making that double bond, and then we can put the other electrons onto the nitrogen. That will make it nice and neutral. That makes our enamine product. And the only step that was different really was that last step here. And so we really have to pay attention because with a primary amine, we can just take the H off of the nitrogen and we're going to be left with an imine instead. With the secondary nitrogen, we have two alkyl groups attached to that nitrogen that's positively charged, so we can't do that. So we have to take the H from somewhere else, and that somewhere else is going to be that carbon that's right next to the H. If we think about like just stepwise for a second, dropping the electrons onto here, they would be resonance stabilized through that double bond. And so that's what actually makes these H's more acidic than any of the other H's that could be on the molecule. They're more acidic than these ones because we can't do the same resonance because we'd be pushing this bond away from the more electronegative atom, which is not favorable. And so we're going to take from the carbon that is beside the carbon that's doubly bound to the nitrogen. So that's where we're taking that H from. We're putting those electrons down to make this double bond, and then these electrons are going up on the nitrogen to make those lone pairs.